don't like first order price discrimination as Berkeley students. Unless you figure out a way to perfectly price discriminate and do your own startup, then you like it very much. Okay? So this is efficient. Competition in the perfectly price discriminating monopoly. They sell the same quantity. They maximize welfare. They have no dead weight loss, but consumers are worse off than they are with a competitive market. I thought that's a pretty cool outcome. Okay, let's do the second type of price discrimination. I'm sorry I'm teaching from notes today, but this is a relatively new lecture, so I want to make sure I don't screw it up too badly. Quantity discrimination is different. We already discussed this a little bit intuitively before, but this is different in the sense that we know that individuals have different willingness to pay or different reservation prices for consumption of a certain number of goods, certain number of units of goods, but we can't identify which consumers are willing to pay more versus others, right? So we know that there are customers that have higher reservation prices and there are customers that have lower reservation prices. So we know that the demand curve is downward sloping. I know there are some of you in here who are willing to pay more for the final than others, for example, or there are some of you that are willing to pay more for nice shirts than others, but I don't know who is who here, okay? So the firm generally knows that most customers are willing to pay more for the first unit than the second unit, right? That's reasonable to assume. You're willing to pay more for the first beer than the second beer, or willing to pay more for the first pair of blue jeans than the second pair of blue jeans. By the way, what's happened in the market for blue jeans is absolutely shocking to me. I don't really like buying pants, but my sister works in fashion, and she always laughs at me when I get off the airplane, so then we have to go pants shopping, and I'm like, $170 for a pair of jeans? Are you nuts, right? You buy 10 pairs of jeans for that. But times are different. Okay, but the point here is, that was a tangent in case you didn't notice. The point here is what the firm is going to try and do, it's going to vary the price that each customer pays depending on the number of units the customer buys. So you see this all the time. Go to any mall at any point in any time, there's at least half the stores have some sort of buy one get one at some discount scheme going on, right? I have a small child. The baby clothing industry is crazy like that. Really, all you need is one, certain number of pants, but you end up with like 27 pairs of pants because of these schemes. So the point here is the only way that price varies is depending on the quantity purchased, not on who you are. I have no ESP, right? But all customers pay the same price for a given quantity. Now, I also want to make sure that when you see different prices for the same good being advertised, so think of magazine descriptions. I know the magazine business is in trouble, but some of you may still read the New Yorker or the Atlantic or the Economist or something like that. If you buy the thing at the airport at newsstand prices, right, you pay $5.95 for the magazine, versus if you buy it, for home delivery, you pay a fraction. You pay like $1 an issue. This is not price discrimination. This all has to do with the cost of getting the good to the customer, right? Getting individual magazines on time to newsstands for people to buy is much more expensive than having anticipated mass mailings of these things to your house. So just because prices are different across consumers and sometimes quantities, it doesn't necessarily mean that that's a form of differential pricing. This goes for quantity and regular types of goods. So let's think about how this works. So that's a tricky one. Where did my ruler go? Oh no. Here it is. Okay. Think of a good whose cost of production is roughly $30. So marginal cost of production is $30. So there's a demand curve that's downward sloping. 3, 6, 9, okay, 9. I'm sorry, I'm talking to myself. I have to get this exactly right. The demand curve is downward sloping. So this is $90. This here is $30. This here is 90 units. Oops. 90. Same thing goes here. I'm going to draw the same thing on both. So this here is $90. Marginal cost is 30. Demand curve intersects at 90. Okay, let's figure out our regular monopolist first. This is the monopolist that charges the same price to all consumers. So what does that monopolist do? Sets marginal revenue equal to marginal cost. Marginal revenue crosses at 45 units. So this person produces, it's not drawn to scale, but I can promise you it's 30 units. 30 units and charges $60. Okay, that's the monopolist. I'm going to use my big dot theorem here. Okay, this is the monopolist. Downward sloping demand curve. Marginal revenue has twice the slope of the inverse demand curve. Marginal cost here is flat because it's easier to draw it this way. It could be upward sloping too. And the monopolist sets marginal cost equal to marginal revenue. That gets you quantity, goes up to the demand curve to get price. So this monopolist charges $60 and produces 30 units. So what we're going to do is we're actually going to put some numbers on our pizza slices in a little while. So let's start with this for a second here. This little rectangle, triangle right up here, it's 30 units wide, it's 30 units high. 30 by 30 is 900, divided by 2 is 450. So this is $450. This rectangle right here, 30 units wide, 30 units wide, 30 units high, 30 times 30 is 900. That's the whole square here. And this triangle right here is also going to be $450. You can't really figure that out without figuring out what that number is right here, but I did that at home. You can trust me that that's right. All right? That's going to be the monopolist. Instead of calling pizza slices A, B, C, and D, I'm going to figure out how big A is, how big B is, how big D is. Now, I'm going to look at a quantity discriminating monopolist. And what the quantity discriminating monopolist is going to do, he's going to charge 70 for the first 20 units, and then 50 thereafter. Okay? So the first price is 70. The second price is 50, right? After the first 20 units, the second 20 units are $20 off. So what the equilibrium quantity here is going to be is it's going to be 40 units, bless you, 70, and then we're going to chop apart some pizza slices here. Equilibrium quantity sold 40 units, and there's not one price. There's 20 units sold at $50 and 20 units sold at $70. So these pizza slices are going to be $200 here, $400 here, $200 here, 400, and 400. So what I want to do is I want to compare the consumer and producer surplus of the regular monopolist, the single price monopolist, to the quantity discriminating monopolist. Discriminator, that's right. So let's figure it out, okay? Here we go. I don't have a lot of room on this slide. That's not nice. We can do it. Consumer surplus, producer surplus, welfare, deadweight loss. And we're going to do this for the quantity discriminator versus the monopolist. Okay, so let's figure out consumer surplus for this person selling 40 units, half of them at 70 and half of them at 50, versus consumer surplus for the regular monopolist. So for this particular quantity discriminator right here, consumer surplus is going to be the area between price and demand over the range of consumption. So for the first 20 units, price is $70. This is demand. So we get $200 of consumer surplus for the first 20 units, and then price drops to 50, and you get another $200 of consumer surplus. Right? So the quantity discriminating market here gets us $400 of consumer surplus. For the single price monopolist right here, consumer surplus is going to be the area, the distance between demand and price over the range of consumption. So it's going to be what I used to call triangle A, $450. Producer surplus is, of course, a little bit different now. Producer surplus, green, is going to be the difference between price and marginal cost over the range of production. So the first 20 units, the price is 70, marginal cost of production is 30. So it's 400 plus 400. For the second 20 units here, it's going to be the difference between the lower price and marginal cost of production. So it's going to be another 400. So this is $1,200 of producer surplus. So total welfare is $1,600. Here, producer surplus for the monopolist is going to be the difference between price and marginal cost over the range of production. It's going to be $900. And that is going to be $1,350. So what happens here? Let me just make sure my math is right. Right? We can compare these two. We know that, for example, under the single monopolist, consumers do better, right? Producers do better under the price discriminating monopolist, and society also does better under the quantity discriminating monopolist right here. Where's the deadweight loss bigger? You can figure it out, right? What's the efficient point of production? It's where marginal cost is equal to price. So this quantity right here, or this quantity right here, it's the same in both pictures. So the total welfare from having the socially optimal point right here is just 450 plus 450 plus 900. It's 1800. So deadweight loss for the quantity discriminating monopolist is 200. And for the regular monopolist right here, it's going to be 450. Pretty neat, huh? So what we've got here is that the quantity discriminating monopolist here actually, again, gets you slightly lower consumer surplus than the regular monopolist right here, gets a huge amount of additional producer surplus, also gets higher welfare than the regular monopolist, and has smaller deadweight loss than the regular monopolist here. But again, it happens at the cost of consumers who lose consumer surplus here. So price discrimination, we're sort of starting to get this picture, in many cases simply does not work in favor of the consumer. Now the last form of price discrimination is going to be multi-market price discrimination, and that one's really easy, right? If you are a monopolist who can set price in different markets, you don't have to set the same price in both markets, but you can sell your wares at a different price in Europe than you can in the US, and you know which group of customers has more likely a higher reservation price than others, what you can do is you can divide potential customers into two or more groups, right? So the example I keep on using is somebody selling a CD or an iTunes song or something like that at a price in a European market versus a US market, but it doesn't have to be a spatial delineation of markets. It could just be by characteristics too, right? So if you get to set a different price to the student market versus the regular people market, you can charge different prices there. How are you going to set that price? So what the firm does is, if it's the only producer of a good that's selling that good to that individual group of people, right, Europeans versus Americans or students versus non-students here, how are you going to act? In that market, you're the only game in town without any close substitutes to production. What's the best way of behavior? Starts with M, continues with ono, and then, yeah, stop it, Max, that is pathetic. My kid thinks that's the funniest thing ever. He now speaks like that. Starts with, but that's how you learn how to spell. But the point here is, you're going to act like a monopolist in each market. So in each market, you're going to look at what the demand curve is, you're going to look at what the marginal revenue curve is, you're going to set marginal cost equal to marginal revenue in each market, and then charge the monopoly profit maximizing price in each individual market. So if you're doing multi-market price discrimination, this is essentially the most boring picture in this entire class. Well, there's a competition for that distinction. But if this here is marginal cost, if you have, let's say, 2, 4, 6 to 10, market 1, and then you have market 2, 2, 4, 6. Here we go. Right? One market, price elastic, one market, price inelastic, demand. Are you going to charge the same price in each market? No. Right? You always, it's profit maximizing to set marginal revenue equal to marginal cost. So what you're going to do here is you're going to figure out what marginal revenue is. You're going to set marginal cost equal to marginal revenue. Bless you. And you're going to set price right here. In the second market, you're going to do the same thing. You're going to set price, marginal revenue equal to marginal cost right here. And you're going to charge a different price, QM. Again, yoga theorem applies here. right? The market with a relatively less elastic demand curve is going to get stuck with a higher price. That should be intuitive by now, but that's not really the question we're trying to answer here. The question we're trying to answer here is how big is the deadweight loss, right? You know the monopoly model good enough right by now to just stare at this picture and see that this right here is the deadweight loss in market 1, and this right here is the deadweight loss in market 2. So there's a deadweight loss in both markets, which immediately lets us jump to the conclusion that this is inefficient, right? If you have a monopolist that has two separate markets and can set the price in the two different markets at will, he or she is going to act as a monopolist in each market, and you're going to get deadweight loss in market 1 and in market 2. So it's just not efficient, right? So student discounts. Yeah, we'll see. So this would be students. This would be well, actually, let's not go there. I don't want to go to the student movie tickets thing because that'll lead to confusion. I think CDs in the European market versus the American market is a much better way of thinking about this. So this is market 2. Now, what you'd want to see here is the first point is this is not efficient, so welfare here is lower than under perfect competition or perfect price discrimination. That's clear. But the comparison that's not clean, and that's going to depend on the setting and the markets you look at and all kinds of different aspects here, is is this sum of deadweight loss in market 1 and deadweight loss in market 2 bigger than if we had this monopolist charge the same price in both markets, right? So if the monopolist added the demand curves in the two markets together and treated this as a single market monopolist problem, it is not clear where the deadweight loss would be bigger, right? It could be better, it could be worse for society, and it really depends on the demand curves and marginal cost curves in these individual markets. So there's no clear prediction here whether a single price monopolist causes a bigger deadweight loss than a multi-market price discriminating monopolist. But that's a little bit, showing that to you really, really clearly is a little bit beyond what we're trying to do here, but I just didn't want to leave it at that and have you think that there's a clear answer that a single monopolist setting the same price in both markets versus the monopolist acting as two separate monopolists, there's a clear prediction as to who causes bigger deadweight loss. All right. I've said all this. All right, but now it's in writing, so it must be true. It's even on the internet. Okay, that was price discrimination. Let's kick markets in the shins some more, all right? Market failure number 4. This is, it's pretty subtle, but I definitely think you can handle it. So asymmetric information is a really cool problem to be working on. We live in an information society. Yes, Max, I know. But information is really, really important. And it turns out that the role of information in economics is a well-studied and incredibly important area of economic research, and also sort of coming up with models that design optimal policies that take into account how people deal with information and what we know about individuals affects what they're going to do, or what individuals are going to do in response to having access to certain types of policies. So the two big problems that we can think of, and there's more than that, but the two big ones I quickly wanted to get across here are adverse selection and moral hazard, right? Those are the two big ones. So you should know what they are. They're subtly different. And there's not always a clear-cut distinction whether it's one or the other, because often in settings you have both going on here. But adverse selection is an informed person benefiting from trading with a less informed person. All right? So this other person doesn't know about an unobserved characteristic of the informed person. So if I offered everyone in the university life insurance at a fixed rate, who do you think would be more likely to actually purchase that life insurance? So same price, same 30-year term life. Who do you think buys the life insurance? Old and sick people, right? So there's some characteristic here. I can observe your age usually by looking at you. You all look very young to me. But I can not figure out who's well and who isn't well, right? So there's an unobservable characteristic. You may know something about your own health state that I, as the insurer, do not observe, where if I offered everyone the same health insurance, I get this issue of adverse selection, that people who are more likely to cash in on the health insurance and leave money for the people they leave behind are likely to purchase that insurance plan. What does this, of course, do in the long run to the price of such insurance plans? They rise, right? So if only sick people select into these health insurance plans or life insurance plans that were designed, we of course don't do this, but initially designed thinking that people were randomly selecting into life insurance and health insurance. Over time, only sick people select into these, and the rates, meaning the number of people who actually die before that insurance policy expires, is much, much higher than the average in the population if you were to randomly sample from the population. So this is this issue of adverse selection where you don't observe something about the other party in your contract, right? Another example here, and that's one we're actually going to build a model for, is when you buy a used car, what do you not know? Is it crappy or is it not crappy, right? So you may have figured out that a Honda Civic is the right car for you. It's attractive, right? Comes in cool colors. It's got a pretty good safety record. It'll last forever. Mine drove for 235,000 miles before I had to change the oil. No, I'm joking. But these things last forever. But within the population of 2003 Honda Civic hatchbacks, are there good ones and are there bad ones? Are they all the same in the used car market? No, right? There's so-called lemons. There's ones that are crappy. They may have been an accident at some point and fixed. In Germany, there's this expression called Montagsauto, which is a Monday car, because the factories don't run on weekends, so whatever car didn't quite get finished on Friday, they pick it up again on Monday. So if your car was finished on a Monday, more likely than not, they forgot to put a certain important part in your car. So the risk of having a bad car that was built on a Monday is much higher than the risk of having a bad car that was built on a Tuesday or Wednesday. So, but do you observe this, right? Assume away